Hi everyone, here is lesson 2 of trigonometry. It's called primary trigonometric ratios. So first we'll do a warm-up. So far we have learned to solve for missing sides of a triangle using the Pythagorean theorem. However, this only works when we have two things: a right or 90-degree triangle. So you have to have a 90-degree triangle, and you have to know two of the three sides. That's the only time the Pythagorean theorem works. So, for example, a builder is about to cut rafters for the roof of a house. The width of the house is 12 meters. That means this, the width of the house. And he has to make the roof 2.5 meters higher in the center than the sides. Okay, so the roof is 2.5 meters higher in the center there than on the sides. If the eaves overhang 0.5 meters, find the total length of the rafter he has to cut. Okay. So the eave overhang is right here. This is 0.5 meters. And of course, the whole rafter this is the rafter here. This whole thing up to the top of the roof. Okay. So what we actually have to do, guys, is we have to figure out this length from this red dot up to the top of the roof. And it's the side of a triangle. All right. So if the width of the house is 12 meters along here, that means that this whole length here would also be 12 meters. Okay, and we're going to assume that the top of the roof is like perfectly in the middle. So we can say that this is 6 meters and this is 6 meters. And here's our 90-degree angle. So you can see we have this 90-degree triangle, 6 meters, 2.5 meters. And remember, across from the 90 degrees is the hypotenuse, C. So we have to figure out that red length, C, first of all. And then we'll add it to 0.5 to get the whole length of the rafter. Okay, so Pythagorean theorem says that c squared is equal to a squared plus b squared. Once we have c established, a and b kind of doesn't matter which one you label a or b, so let's say that a is the 6, so we'd have 6 meters squared plus c is 2.5 squared. And let's work this out. This means that c squared is equal to 6 squared plus 2.5 squared. So that's 42.25. And then, of course, to get c by itself, we have to square root. And remember, the plus or minus technically can work mathematically. So c is equal to plus or minus the square root of 42.25, which is 6.5. And we're going to reject the negative answer because we're finding the length of a side, and we're going to say that c is 6.5 meters. Okay. So c is 6.5 meters, and then we have the 0.5 meter overhang. The eaves overhang 0.5 meters. So we can say, therefore, the total length of rafter is equal to 6.5 meters plus 0.5 meters for a total of 7 meters. Okay, so that's a nice little review of the Pythagorean theorem. Today we'll learn how to find sides when we are not given two sides. In order to do that, we must be able to know a few terms in basic trigonometry. So, naming sides, in a 90-degree triangle, the slanty or longest side, it's always across from the 90 degrees. That is called the hypotenuse. So if I draw a little picture, there's our 90 degrees, and across from the 90 degrees, slanty side, it's always the longest side, and that's called the hypotenuse. The side opposite the angle you know or want to know. So let's say that we know this angle right here. I've labeled it alpha, that's called. We use Greek letters for angles, and that's the Greek letter alpha. Okay, so let's say that that's kind of the angle that we're interested in, or that's the angle we know the measure of. Then the side that's opposite that angle is naturally called the opposite side. And the side beside or touching the angle you know or want to know, a fancy word for beside is adjacent, and so this side here is called the adjacent side because it's beside our angle. And you may notice, guys, that the opposite and adjacent labels, those will actually switch if we are talking about the other angle. So we've got a 90-degree triangle. Across from the 90 is the hypotenuse. Let's say we were interested in this angle, or we knew this angle in the upper corner there. Let's call it beta. So then right across from beta is the opposite side, and the one beside it would be called adjacent. Okay, so you can see how opposite and adjacent, those labels can switch. Kind of just depends on which angle we're interested in. All right, let's try example 1. Find the length of the side that is the hypotenuse. Okay, the hypotenuse is across from the 90 degrees, so that is 13. Adjacent to alpha, so the one that is beside alpha is 5. And how about opposite to alpha, straight across like that, is 12. Let's try example 2. Find the length of the side that is the hypotenuse. Across from the 90 degrees is 15. Opposite to epsilon, that's the little Greek letter epsilon. So opposite to epsilon is straight across from epsilon, and that is 12. And adjacent to beta, okay, well, opposite to beta would be like that, so adjacent would be the one right beside it. because the one across from the 90, this is the hypotenuse, right? Okay, so opposite to beta is like that, and so adjacent is the 12. And you'll notice, guys, that when we get onto the next page, we've got one more question that applies to the one up above here in example 2. Opposite to beta. And if you look at beta, and if I do that line all the way opposite to beta, that's the side length 9. Now we'll look at what are called the 3 primary trigonometric ratios. That's sine, cos, and tan. But we'll talk about that in a second. So there are 3 right-angled triangles in the diagram below. Name all 3. So the first right-angled triangle is this little one. It goes from A to B to M. That. Okay, the second one is the middle one. It goes from A to C to N. And finally, the third right triangle goes from A to D to P. A, D, P, like that. And here's what it wants us to do. It says measure the opposite side and the hypotenuse for each triangle and divide them. Okay. So we'll start off with triangle ABM, the smallest one. We'll go opposite over hypotenuse, and it's opposite to this angle theta that they have labeled. All right, and so there's the opposite side. And here's the hypotenuse across from the 90-degree angle. Okay. And I did this with a ruler, and if you measure it, you end up getting this. The opposite side is about 0.9 centimeters. And if you go opposite divided by hypotenuse, we get 2.9 centimeters for the hypotenuse. I did that with a ruler. And when you divide these two, we get a ratio of 0.31. Now we'll do this in the middle 90-degree triangle, which is triangle ACN. Here's our angle in question. The opposite side is this. So here's the triangle we're talking about. You kind of have to forget about that line down the middle of this triangle for a minute. Opposite to angle alpha is there. And the hypotenuse is up here because here is the 90 degrees and across from the 90 is the hypotenuse. So if you measure these with a ruler, you get 1.4 centimeters divided by, the hypotenuse ends up being 4.5 centimeters, and you essentially get, if we round to 2 decimal places, 0.31 again. Now let's do the last one in triangle A, DP. Opposite to alpha is that guy. Across from the 90 would be this whole big side here. There's the hypotenuse. If you measure the opposite with a ruler, you get 1.8 centimeters. Divided by, the hypotenuse is 5.9 centimeters. lo and behold, look at what we get again to 2 decimal places, 0.31. So in each triangle, the fraction ratio of opposite over hypotenuse is 0.31. This ratio will be the same as long as the triangle has the same angle. Okay, so as long as this angle here, this alpha, remains constant, let's say it was like 25 degrees. Okay, as long as you have a 25-degree angle, you can draw any 90-degree triangle with that, and the ratio of opposite over hypotenuse will always be the same. This ratio will be the same as long as the triangle has the same angle. This ratio is called the sine ratio. Okay, so when you do opposite over hypotenuse, we give that a special name called sine. There are two other primary ratios. Cosine and tangent, which we abbreviate as cos and tan. The cos ratio divides adjacent by hypotenuse, and the tan ratio divides opposite by adjacent. To remember all this, we have a little word that you will write on every worksheet from now on. SOHCAHTOA, it's called. It's an acronym. SOHCAHTOA, and it just stands for the sine of an angle is opposite over hypotenuse. So see how S stands for sine, and then OH, opposite hypotenuse. Ka is cos, is adjacent over hypotenuse, and TOA means that tan is the opposite side divided by the adjacent. And these are the primary trig ratios. And they only work in 90-degree triangles. Now we have enough information to be able to find the ratio of a given triangle. Example 3, find the indicated ratio in fraction form. Sine of beta. So beta is right here, and you just have to remember that sine is opposite over hypotenuse. The opposite side is 5. And the hypotenuse is across from the 90, which is 13. Okay, so sine of angle beta is 5 over 13. Cos beta, cos is adjacent over hypotenuse, so if the 5 was the opposite, the adjacent would be here. Cos beta is 12 over 13. And finally, tan beta, if you go up here, tan is opposite over adjacent. The opposite side to beta is 5, and the adjacent is 12. Okay. Now, things switch around a little bit if we are talking about angle epsilon. So notice the next little part is cos epsilon, sine epsilon. Oh, and then it's got tan beta. So really that second beta should be an epsilon, so let me fix that. Tan epsilon. Now, the hypotenuse side, that always stays in the same spot, right? It's across from the 90 degrees. Okay, but if we're talking about epsilon now, that means that the 12 is the opposite side, and the side beside epsilon is the adjacent, the 5 here. Okay, so cos of epsilon, cos is adjacent over hypotenuse, so we've got adjacent over hypotenuse, so that's going to be 5 over 13. Sine of epsilon, sine is opposite over hypotenuse, so it's going to be 12 over 13. And tan of epsilon goes SOHCAHTOA. Tan is opposite over adjacent, so there's opposite, 12, and the adjacent is 5, 12 over 5. All right, example 4, find the indicated ratio in fraction and decimal form. So first of all, if we're talking about beta, this is the opposite. This would be adjacent, and across from the 90 is the hypotenuse. So sine beta, sine is opposite over hypotenuse, so that would be 15 over 17. And let's do that in decimal form. Maybe to 3 decimals, 0.882. And tan beta, tan is opposite over adjacent. The opposite is 15, and the adjacent is 8. So 15 over 8 is 1.875. And now we will switch gears, because we are talking about angle epsilon. Epsilon is here, so the opposite side is the 8, and the one beside it is the 15. That's the adjacent. Hypotenuse is always across from the 90. Cos of epsilon, cos is adjacent over hypotenuse, so that would be 15 over 17. Well, we already worked that out before, so that's 0.882. And sine of epsilon, sine is opposite over hypotenuse, so 8 over 17. And that is 0.471, let's say. 2, 3 decimal places. All right, now to find trig ratios, we could draw a triangle that had the appropriate angle, measure the proper sides, opposite and hypotenuse if you wanted sine, adjacent and hypotenuse if you wanted cosine, etc., and divide them. However, this would be time-consuming and inaccurate. Luckily, someone has already done these and given them to us in the form of trigonometric charts. You have this built into your scientific calculator. Therefore, you can use your calculator to find the sine, cosine, or tangent of any angle you want. Note, just make sure your calculator's angle is set on degrees. Okay, so in example 4, we are going to find the appropriate ratio in decimal form to 3 decimal places. So I'll get out my calculator and I'll show you mode that I am changing this to degrees. And notice that degrees now is highlighted in black, and I'm going to quit. And we are going to do sine of 30 degrees. So you press the sine button and then go 30. I'm going to close the bracket and we get 0.5. So just to give you an idea of what that means, I'm not going to do this with every single angle. After this, we'll just figure them out. Sine 30 equals 0.5. What that means, guys, is if you were to draw a 30-degree angle right here, it means that the opposite side divided by the hypotenuse, that's what sine is, it would mean that this opposite divided by hypotenuse is equal to 0.5. That's what sine 30 equals 0.5 means. All right, let's do some of the other ones. Cos 88 is 0.03, let's say. Because this is asking for 3 decimal places. Cos of 15 degrees is 0.966. Tan 45 is equal to 1. How about tan 55? 1.428. The last one there is sine 75 degrees. 0.966. To go back from the trig ratio to the angle, you are dividing by the ratio. Just hit shift or second function sine or cos or tan. Okay, so for example here, find the appropriate angle to the nearest degree for the following ratios. So this time we've got the ratio here 0.0523. That's the opposite side divided by the hypotenuse in the triangle. And when you divide the two sides, you get that ratio. So we want to know what angle does that come from. And so what you have to do is you have to use shift sign. And shift sign is underneath the regular sign button. You can see in yellow it's like sine to the -1, and same for cos and tan. So you would just go second function sine, you get sine to the -1, put in the ratio of the two sides, opposite divided by hypotenuse is the 0.0523, and press enter, and it gives us the angle of about 3 degrees. So it says find the appropriate angle to the nearest degree. So the nearest whole number. So we would round that to 3 degrees. Okay, letter B, we have to go second function cos, 0.978. And we get about 12 degrees for this one. And letter C, I have to go second function tan, 0.625. And we get 32 degrees for this one. For letter D, you go second function tan, 57.290. And we get about 89 degrees. Letter B again, little typo there. Second function sine, 0.454. 27 degrees for this one. And finally, letter F, second function cos, 0.999. About 3 degrees again. All right, and finally, let's learn how to solve for a missing side given the ratio of an angle. Just cross multiply and solve. So in example 6, we're going to solve for x. So x is being divided by 10. X divided by 10 equals sine of 45. So to get x by itself, multiply both sides by 10. So 10 times sine 45 is equal to, the 10's cancel, 10 divided by 10 is 1, is equal to x. So x is equal to, in the calculator you can just go 10 times its regular sine now because we have the angle sine of 45 degrees. 7.07. So let's just say 7.1. In letter B, cos 31 equals x divided by 4.8. So to get x by itself, multiply both sides by 4.8. And we get 4.8 times cos 31 degrees equals x. So x equals 4.8 times cos 31, 4.1. And the last one is a little bit different. This time it's 12 divided by x equals 1083. So we have to multiply both sides by x first of all, and that gives us x times 1083 equals x divided by x is just 1, so that equals 12. And you notice that x is not by itself yet, it's being multiplied by 1083 now, so you have to divide both sides by 1083. That cancels to 1. So now x is equal to 12 divided by 1083. And if you kind of look at the original question here, equals 12 over x, we now have that x is equal to 12 over 1083. So it's kind of like the x and the 1083 just sort of switch spots. That's a quick shortcut you can use. 12 divided by 1083. Bang. 1.5, let's say. All right, and so that is lesson 2 for trigonometry, everybody. You can see that the assignment is here, but look at the answer key. Questions 1 to 4 will be marked in class, and then there's just answers for number 5. So I was going to quickly write down the answers for 1 to 4. Okay, no peeking yet, guys. Make sure you go and try it, and then come back to the video here and check your answers. Okay, so let's do number 1 again. Give them a try first, guys, and then come and check your answers. Make sure you know how to do this. Okay. Sine of alpha is opposite over hypotenuse, so 7 over 25. Cos of alpha is going to be 24 over 25. Tan of alpha will be opposite over adjacent, 7 over 24. Sine beta is going to be 24 over 25. And then we're on to the next one, or does it carry down? Oh, it does carry down. We'll look at that. Okay, cos beta. Beta is there. Adjacent over hypotenuse is 7 over 25. And tan beta is going to be opposite over adjacent, 24 over 7. And in letter B here, sine alpha is going to be 6 over 10. Cos alpha will be 8 over 10, and tan alpha will be opposite over adjacent, 6 over 8. Sine beta will be 8 over 10. Cos beta will be 6 over 10. And tan beta will be opposite over adjacent, 8 over 6. And letter C, sine alpha is 12 over 13, cos alpha is 5 over 13, and tan alpha is 12 over 5. Sine beta will be 5 over 13. Cos beta will be 12 over 13. And tan beta will be opposite over adjacent, 5 over 12. Number 2, write the required ratio in fraction form and decimal form. Okay, sine beta is 10 over 26. Let's go 3 decimal places, I guess, 0.385. Tan theta, that little 0 with a belt is the Greek letter theta. Tan is opposite over adjacent, 24 over 10, which would be 2.4. And cos theta is adjacent over hypotenuse, 10 over 26. 0.385 again. Tan of alpha is opposite over adjacent, so 10 over 24. 0.417. Cos theta is adjacent over hypotenuse, 10 over 26, which we have already calculated as 0.385. And sine alpha is opposite over hypotenuse, 10 over 26 again. 0.385. Number 3, find the required ratio in decimal form to 3 decimal places. Okay. Sine of 20 degrees, 0.342. Sine 65, 0.906. Cos 63, 0.454. Sine 17, 0.292. And tan of 37, 0.754. Cos 37 is 0.799. Tan 89 is 57.29, let's say. Cos of 1 degree is 0.9998, let's say. Sine of 24 is 0.407. Tan 52, 1.280. Tan of 80 degrees is 5.671. Sine 72.951. Tan 18 is 0.325. Cos 46 is 0.695. And tan of 45 degrees is 1. Okay, and so of course, again, what that means, guys, is if you have a, that's not a very good diagram. is if you were to draw a 45-degree angle, tan, you know how there's the 90, so there's the hypotenuse. Across from the 45 is the opposite, meaning this would be the adjacent. Tan stands for opposite divided by adjacent. So if you've got a 45-degree angle, it's saying that opposite over adjacent is equal to 1. The opposite side and the adjacent side would be equal if you've got a 45-degree angle. Okay, because anything divided by itself is equal to 1, so it must mean that opposite and adjacent are equal when you're at a 45-degree angle. Okay, and finally, number 4. This is where we're going to have to use shift sine, shift cos, and shift tan, it looks like. Find the angle that you would give that makes no sense, that sentence. Find the angle that would, oh no, okay. Find the angle that would give the given ratio to 1 decimal place. All right, so I have to go shift sine 0.4384, 26 degrees. And letter B, shift cos 0.0698. That's basically 86 degrees. And the last one here, shift cos of 0.3746. And we get 68 degrees. Letter D is shift tan 6.3138. 81 degrees. Shift tan of 0.1405. And we get about 8 degrees for this one. Shift sine 0.8290. About 56 degrees for that. Shift cos 0.6157. Get 52 degrees for this one. Shift sine 0.9563. 73 degrees for this one. Shift tan 1.6003. 58 degrees. Shift sine 0.2432. 14 degrees. Shift cos 0.4115. Bang. 66 degrees. Shift tan 0.4773. 26 degrees for that one. Shift cos 0.9126. 24 degrees. And shift sine 0.1392. It's about 8 degrees. And finally, second function tan, looking for the angle, 6.3138, 81 degrees. Okay, so just as an example, tan of 81 degrees should be really close to that 6.3138 ratio. 6.31, there we go. Okay. So when we actually did shift tan of the original ratio, we got something close to 81. We rounded it to 81, and so that's why you get a little bit of difference. Okay, there you go, everyone. That is Trig Lesson 2. Did some homework questions for you. The answers to number 5 are shown down below. Again, let me know if you have any questions, and I will send you another learning task next week.